Hello everyone. Good evening, everyone, those of you are watching right now. We'll begin with first of all, let me introduce myself. Okay. So, we'll wait for a few minutes, 1 minute or something like that, and then we'll begin the session. So, let's start with the introduction part. My name is Jay Dalsaniya, and I work as a mentor at Geeks for Geeks, and I have been working with an edtech company from I've been in the edtech industry from past let's say 2 years, and I am into teaching DSA. Okay. Hello Rishit. We'll begin with the problem of the day. So I'll be taking today's problem of the day, 14th March, and let me share the screen. So can anyone from the audience just give me a confirmation whether my voice is clear and loud enough or not? Because that would help me to uh, begin the session, and it will clarify my doubt. Just quickly write down in the chat box that my voice is audible clearly and just quickly write down in the chat box. Okay, I think it's audible properly. So we'll begin with the session. Today's problem of the day, 14th March, was maximum number of coins, and this question was asked in Make My Trip. Okay. I can see confirmation from everyone. Okay. The name of the question is maximum number of coins. Okay, so let's first of all read the problem statement. Let me just give you the idea like how I will be delivering the logical part and everything. So first of all, we'll be discussing the problem statement. We'll take a look at the examples and different test cases as well, which are not available in this along with the question. And then I'll be introducing like what is the brute force approach, how we can solve in a brute force manner, and then we'll try to optimize it, and we'll see the optimal code at the end. And I'll be sharing the link of the code in the description box. Okay, I'm like good, Yasir. Thank you for asking. So let's begin. We are given n balloons, okay, and each with a number of coins associated with it. So on bursting a balloon I, the number of coins gained is equal to a of I minus 1 into a of I into a of I plus 1. Okay, so that's a multiplication of three adjacent numbers. So also a balloon I minus 1 and I plus 1 now become adjacent because the middle balloon has burst, and so the remaining adjacent one will be the new adjacent. So find the maximum possible profit earned after bursting all the balloons. Assume an extra one at each boundary. Okay, so let's dive into the explanation part. So I will take the example. So what the question is trying to say, let's say you will be given an array containing the value of coins associated with each and every balloon, and you have to burst the balloon. Let's say you are trying to burst the ith balloon, then what is the amount of coin generated? So that would be the multiplication of the value present at the I minus 1th index into array of I into array of I plus 1. Okay, so this will be the total number of coins gained after bursting the ith balloon. Okay, and the question is saying that you have to assume that there are ones present at both the ends. Okay, this is the input array, and there are ones present at both the ends. You will be understanding what is the reason behind this after understanding how to solve this test case. So let's say what is the question. The question wants you to find out that in which pattern, like let's there is an optimal pattern in which you burst the balloon, you will get the maximum number of coins, and that is the question, and you have to output that what can be the maximum number of coins. Okay, so over here for this arrangement, let's say I'm trying to burst the balloon this 5. So what will be the profit generated? That would be the 1 into 5 into 10, so that would be 50. So now this balloon has been blown off. So now how many balloons are remaining? Only one balloon, and there are ones present in both the ends. So now I can burst this balloon. So currently I'm having a profit of 50. So bursting this balloon will give me 10 into 1 into 1, so that would be 10. So 50 plus 10, and the final answer comes out to be 60 in this case, and this is the optimal output. Okay, was the this question clear to you, Malab? This test case, Any doubt with this test case or the question understanding any of the part? Just quickly write down yes or no in the chat box, so I'll get a confirmation. Anyone? Quickly write down in the chat box. Any doubt till now? Okay, continue. Okay, so the one more test case. Okay, let's take one more test case. So there can be different possible arrangements as well. So I'll take one more test case: 1, 3, and 5 and 8. Okay, so this is the input number 2 given to us. So now, in order to find the maximum output, there are many possibilities, right? So I can start with bursting the first balloon. I can start with bursting this first balloon. So on bursting this balloon, I'll get a profit of 1 into 3. And according to the question, imagine 1 present at both the ends. So moving on, so currently I'm having a profit of 3. So how many balloons are remaining now? 3, 5, and 8. So let's say I'm trying to burst this balloon. Okay, so which part, Amarasi, Amarsai? Okay, so you'll get to know while explaining this part. Okay, so 3, 5, and 8. Let's say I'm bursting this 5. So what will be the profit generated? Currently I'm having 3, so that would be 3 plus 3 into 5 into 8. 8 5 are 40, 43 plus 3, and that would be 46 currently. And how many balloons are remaining? 3 and 8. So over here 1 and 1, I'm just trying out one of the possibilities. So let's say I'm bursting this 3, so that would give me the profit of, currently I'm in 46. 46 plus 1 into 3 into 8, 8 is 24, 46, that would give me 70. Okay, and so on, and at the end you will be having only one balloon, and that would give you a profit of 8. So 70 plus 8, and currently at the end you will be having 78 as your profit. So this is one of the possibilities in which you can burst the balloon. Okay, so there would be another optimal approach as well in order to burst the balloon, and that is given over here along with the question, that over here for 3, 1, 5, and 8. So first of all, let me turn off my camera so that won't be causing any issue over here. Okay, so 3, 1, 5, 8. So over here, in this arrangement you can observe that 3, 1, 5, and 8. So this balloon was burst and you got the profit of 3 into 1 into 5. So 3, 5, 8 are remaining. So again you try to burst this balloon 5, so you'll get a profit of 3, 5 into 8. And this 3 and 8 is remaining, and you try to burst this 3, so you'll get 1 into 3 into 8 as the profit. And over here the coins are being added up, and this 8 is remaining, and at the end this was the optimal process in which you can burst, and then you get the output as 167. By now I guess everything is clear to you for the question. So okay, and let's observe the constraint as well. So n is the number of elements, or the number of elements in the array, and it can go till it can start from 1 and end at 400, while the array elements are having the range 0 to 100. Okay, so let me give you one more example, a smaller example, so you I guess most of your doubts will be cleared out. So if there is only a single element, and according to the question, understand, like you have to figure out that there is a 1 present at both the ends. So this will give you the profit of 10, because 10 into 1 into 1 will give you 10. And now how many balloons are remaining? 0 balloons are remaining. Remember this thing, this 1 and 1 are only for the calculation, they are not the balloons. Okay, so do not confuse yourself with this thing. So some of you might be doing this thing again and again and imagining one over here. So this will keep on going and going, but you don't have to consider this one as a balloon. Okay, and this is the profit for 10. A single element will give you a profit equivalent to its value. Okay, so now this was the entire question understanding. I hope there is no doubt regarding this part. So now let's understand how we can solve this. Till now you might have got the idea that we can try out all the possibilities. Okay, so that can be our brute force approach, isn't it? Can anyone give me some idea regarding the brute force approach? I would like to hear from you guys. Anyone in the chat box, quickly. I'll give you a minute. It's 12:09, so like 12:10. Please repeat input 2 again. Okay. Okay, till then I am giving time to everyone else try to figure out some of the brute force approach. So input number 2. Okay, so In input number 2, I have taken an array which contains 1, 3, 5, and 8. Okay. And over here, you have to find out what is the maximum output which you can get. So if you want to get the maximum output, there is some process like you can start bursting the first balloon. If you burst the first balloon, then you'll get a profit of 3, and this many balloons are remaining. So you can choose this balloon or this one. So I choose this 5, and on bursting this 5, I get a profit of this much. That comes out to be 43, and total currently I'll be having 46. So this balloon is out of consideration, and now 3 and 8 are remaining. So I can choose this one or this one. So I choose 3, and so on. Yes, and factorial. Okay, so okay. Yasir Ali, was it clear? Okay, Rishit is saying at each step we can try to pick an unselected balloon and burst it and add the coins to our answer. At each and every step we can. Okay, so basically, if you want to summarize that thing, you can try out bursting all the balloons one by one. So what does that mean? Let's understand. Okay, so now here comes the algorithmic part, brute force part. So this question is not at all difficult if you know the the standard problem. Okay, I'll tell you which of this standard problem. It is a variation of a standard problem. I'll explain that part as well. 19785. Okay, so that's a very big array, so it will take much time to explain the optimal one. But I can give you the final answer at the end. So for the brute force approach, what you can do? So okay, I'll take 19785 over here. Okay, and this is the input, and this is 1 and 1 over here. So now if I want to find the optimal output, so at the first go, how many possibilities do you have? Like how many balloons can you choose from? You have n number of balloons, right? And over here n is equal to 5 in this case. You have a possibility of 5. You can choose this one, this one, this one, or any one, right? So let's say you are choosing any of the balloon. Let's say I'm going with this one. Okay, if I'm going with this one, then how can I get the maximum output? So maximum output will be nothing but if I consider this partition as P1 and if I consider this partition as P2, then the brute force approach will work like this, that each and every step what I'll be trying, let's say I'm bursting this balloon and this is the partition 1 and partition 2. I'll try to find out that what is the maximum output for partition 1, and that would be my A1, and what is the maximum output for my partition 2, that would be my A2. Okay, so if I get this A1 and A2, these are the maximum for partition P1, that considers like it is covering this much of part, this many balloons, and this P2 consider is covering this many balloons. Okay, so now I will be bursting this balloon number 9. So how will I burst this? So if after calculating the output for P1 and P2, how many balloons will be remaining? Only 9 will be remaining, and over here 1 and 1 will be remaining, and you will be having A1 and A2 as your answer for partition 1 and partition 2. So now only one balloon is remaining. So what you will be doing? You will be calculating 1 into 9 into 1, because that is the profit you get by bursting this balloon 9. And what is the total profit you get? So A1 is the maximum of P1 and A2 is the answer for maximum of P2. As this is maximum and this is the maximum value, so on bursting this balloon 9, what is the maximum value you can get in this manner? You can get that answer by finding the value A1 and value A2, that is maximum profit by bursting the partition 1 and maximum profit by bursting all the balloons in partition 2. So if you get this maximum and this maximum and you add the value you get by bursting balloon 9, you will get the output that what is the maximum value you can get by starting by bursting balloon number 9, by bursting balloon number 9. Okay, so in this manner you can proceed out. So I got the output for 9. I got, let's say, I'll call it as T2. Okay, so on bursting the balloon 9, this is the optimal output. That is T2 is my optimal output. On bursting the balloon 1, let's say T1 is my optimal output. On bursting the balloon 7, T3 is my optimal output. And bursting the balloon 8, I get the T4 as my maximum output. And on bursting balloon 5, I get T5 as the output. So the overall answer will be nothing but a maximum of T1, T2, T3 and T4 and T5. And this will be the output. This will be the output for any test case. Try to think on this part. This T1, T2 and T3. Are you getting my point? Yes or no in the chat box quickly. So you have to find out that what is the maximum output you get by bursting each and every balloon, and from that set of numbers you will choose the maximum one, and that would be the maximum or the output for the given test case. For partition 1, what will be the rightmost cell of row 1? So, okay, so for the corner ones, for the corner balloons, 1, let me change the color, 1, 9, 7, 8, and 5. Okay, so if I'm considering this one, for it, the partition 1 will contain nothing. So that is the A1, that is the maximum output you can get by bursting all the balloons in partition 1. Nothing is present at this part. Partition 1 contains no balloons. For partition 2, you can have some value A2. And this will be your base case. Okay, I'll explain what is the how you will handle this part. Okay, and similarly for this 5, if you are considering this 5, 1, 9, 7, 8, and 5, it will not have partition 2 because there is nothing present on the this side. So its answer maximum output will be 0, while for partition 1 you will have something as your output. Okay, I hope this was clear to you. So you have to find out that what is the maximum output you can get by bursting each and every balloon. So okay, so let's say I am starting over here in this manner. If I am starting in this manner, I am choosing 9. Okay, so if I want to find the maximum out of partition 2, if I want to find the maximum output for partition 2 and partition 1, so this partition 2 becomes one more sub problem, that if I want to find out the maximum output for partition 2, I again have a sub array, and I in this sub array also I have three different choices. Okay, I have three different choices, so I can find out what is the output which I'll be getting by considering each and every balloon as my choice. What is the output? What is the maximum output I can get by bursting 7? Let's say it's T11. What is the maximum output you can get by bursting 8 first? So that would be T12. And for 5, let's say it is T13. So for this subarray, the output will be nothing but it will be the maximum of this one. So in this manner, you will get the output A2 for P2. Okay. So in this, again, there is a recursive problem occurring. So if you want to find T1, this is your partition 2 for this subarray. So you are again having a sub array 8 and 5, and in this 8 and 5 you have to find out what is the maximum number of coins you can get, right? So this is again the same sub problem. So basically I am having different sized sub arrays, and on that sub arrays I have to find the maximum number of coins I can get. But when we burst the balloon, P1 and P2 become adjacent to each other. Okay, so on bursting this P2, if you burst this sub array, nothing will be present. No, if you burst this P2, if you are finding the output for P2, then that means you are bursting all the balloons present in P2. Similarly, if you are finding the output of P1, you are busting all the balloons in partition 1. So if you burst all balloons in partition 1 and partition 2, what will be remaining? Only the single element, this around which we have done partition 1 and partition 2, will be remaining, right? And for P1 you will be having some output, and for P2 you will be having some output, right? And you will be having two different outputs. And now on busting the balloon 9, what is the profit you get? So that would be the sum of A1 A2 and 1 into 9 into 1. So this is the output you get, maximum output on choosing 9 as the first balloon to start with. Is it clear, Ritesh Chaudhary? Was it clear? Okay, when I am saying this thing that I am finding the output for some partition, then that means you are busting all that balloons in that subarray. Okay, so this is the idea which I am trying to explain. Okay, so over here we can see a recursive approach is applicable, because there are different sub problems, and those all sub problems require the same algorithm. Okay, so this question is nothing but a simple modification of matrix chain multiplication problem. The matrix chain multiplication problem is a standard problem, right? So if you are trying to solve some problems in which you have to try out different points, and you have to find out different values around that pivot point, you can call it as a pivot point, and that is again on partitioning around the pivot point, you will get two different partitions, and the output for both those partition can only be given by again doing the same process. So this kind of thing is what the standard question matrix chain multiplication does. Okay, so I'll give you an idea about the algorithm which you generally need to follow. If you do not know matrix chain multiplication, do not worry. So I'll give you a general technique that all the variation of MCM, that is matrix chain multiplication, can be solved using this pattern. Okay, so this pattern, I'll explain that pattern as well. Yes, exactly. Yes, Rishit. So we only burst the pivot point after we burst all the balloons in partition 2 and around it. Yes, exactly. So if you burst all the balloons in around it, so there would be nothing remaining on both its side, right? On left and right hand side, nothing will be remaining. So that is how we will be proceeding. We always burst minimum balloon. Okay, no, you have to find out that you cannot always choose the minimum balloon, right? Because how that won't give you the final output. Like if you try on different test cases as well, so if you choose minimum each and every time, the greedy technique is not going to work. So I'll be trying out all the possibilities. Okay, so let me give you, I was talking about MCM, right? All the variations of MCM can be solved with this technique. So the variation, all the problems of MCM will be having some kind of partitioning part, that if you want to find out the final output, you can try out the partition around this pivot point, you can try out the partition around this pivot point, you can try out partition around this pivot point, and so on. So all the variations of MCM will be following this pattern. So if you find any problem that is having the same pattern, you will be needing a simple algorithmic step, that this is the algorithmic step, and in this algorithmic step you simply need to fill up all the formulas, and that's it. All the variations of MCM can be done in this manner. Okay, so this will make your task very much easier. Okay, so let me give you quickly an idea, and then we'll be also optimizing it directly to DP as well, and that would be a very quick and easy transition. Okay, after you get an idea how the problems of MCM are solved. Okay, so the problems of MCM have a general uh like, what do you say, a standard thing. So you will be having some partition, and that partition will be defined by I and j. These are the boundaries, and you will be trying out all the pivot points between this partition I to j. So there would be some pivot k which will be iterating over this partition again and again from I to j. And at each and every value, you will be trying to find out that what is the maximum output you can get. Okay, and then you will be having the partition P2, and for on that partition P2 you'll be following the same process again and again. Okay, so let me give you that algorithm. So that algorithm goes like this. So you'll be having a function and you will be having an array, and there would be the boundaries I and j. Okay, so if you want to find out what is partition 1, you will be having some formula that in this range I to k, I'll be considering only I to k minus 1 as my partition 1, I to k as my partition 1, or anything. That depends upon your question. Let's say I'm considering I to k in my partition 1, then for partition 2, how many elements are remaining? That would be from k plus 1 to j, right? That would be in my partition 2. But this thing, division of partition depends upon the question. Okay, so I'll be giving you the partition technique for this question. Okay, so first of all, let me complete this entire thing. So there would be some base case. As this is a recursive function, there would be a base case required. So that same thing, base case thing, will be mandatory over here as well. And over here there would be iteration over pivot points. Iteration over pivot points. Okay, so I and j is the boundary, so I'll be having a pivot k which will be iterating over the range I to j. For example, k is lesser than or equal to j over all the values. Okay, so I'll be calling a function, I'll be making a function call for partition 1, and for partition 1, let's say I'm considering the range I to k. For example, this also depends upon the question. I'm just simply giving you the idea that how you can solve this. Let's say I'm considering I to k minus 1 elements in my partition 1, and I'll be considering, let's say I'll be considering I k plus 1 to j elements, all these elements that would be from k plus 1 to j as my partition 2. This is my partition 1, for example. Okay, and there would be some formula which you know need to apply on that pivot point, or let's say calculation on pivot point. And on this, all these values, this value t1, t2, and t3, you apply some mathematical formula that if the question wants you to maximize, you apply some maximization. If the function or the question wants you to minimize, you apply the minimize kind of minimization. Since on both the sides no balloons will be left. Okay, so let's say the operation which you apply on the values written by partition 1 and partition 2 is, suppose, addition. So the value written by partition 1 will be added to partition two's value and over here, and you will be getting a temporary answer in this manner. If I keep the pivot point at this thing at value some, let's say this is the value for partition 1, this will be the value for partition 2, and this will be the value around the pivot. Okay, and on this, let's say addition operation was applied, this will be getting, I'll be getting a temporary answer as the k value is iterating over all the values in the range I to j. At each and every point I'll be getting a temporary answer, and I'll be choosing the maximum of this temporary answer, and that would be the answer for this partition I to j. So I'll be having one more variable, answer variable, and in this answer variable, the maximum of all the temporary answers will be stored. Maximum of answer and temporary. This is a very simple thing. Okay, nothing fancy over here. Okay, so this much part, and as you have got the output answer for the range I to j, and it is stored inside your answer variable. It is stored inside your answer variable, and you will be returning the value of your answer variable from this function at the end. So you can simply return the value of your answer variable, and that's it. So this is the algorithm which all the variations of matrix chain multiplication follow. Is it clear? This part, is it clear or not? Quickly, yes or no. So I'll get a confirmation. Because this is very important to understand, because I will simply fill all these values. I'll be simply adding what is the base case. I'll be adding the base case for this question. I'll be adding the calculation part on pivot for this question, and you'll get a recursive function which will be the which will try out all the possibilities. Okay. Yes or no? Quickly in the chat box. Any doubt or anything? I think okay. So I am getting no response from you guys. Okay, so let's. I think it's clear to everyone. Can you scroll down to the last two lines? Okay, last two lines. So this is finding the maximum of all the temporary values and returning the answer. This is the output, optimal output for range I to j. That will be inside your answer variable. Yeah. Okay. Okay. So now here let's modify this algorithm according to our question. Okay. So now we'll be modifying this basic steps into our solution for this test case for this question. Okay. So now how will you do that? So first of all, we need to understand this pivot point. Okay. So at each and every step, let's say I'm talking about the sub array ranging from I to j. So from which value to which value my pivot should iterate, whether it should start from I plus 1, that k should start from I plus 1, or k should start from I, whether it should end at the value j or whether it should end at the value j minus 1. So how will you understand this thing? So how to figure this thing? So this is the most critical part in all the variations of MCM. Okay. So over here, in order to figure this part, as I mentioned while explaining that I'm trying out all the possibilities by bursting the balloon at each and every position. So that means at ith position, I'll burst that balloon and find out what is the maximum output. At I plus 1th position, I'll do that same thing at I plus 2 and so on, and at jth position also. So the for loop, the inner for loop, the pivot for loop will run from I to k is lesser than or equal to j. That is, it will run on the range I to j. Okay, so this pivot point will run on the range I to j. Okay, this pivot point, I figured out that this is my pivot point. It will be running on the range I to j. So now what will I include in partition 1 and partition 2? So I need to figure out what will be the range, whether it will be from I to k, and let's say partition 2 will be from k plus 1 to j, or what. So for that, again back to the point which I already declared, that I'll be bursting the kth balloon. I'll be bursting the kth balloon. Okay, so what does that mean? Let's say for this subarray, okay, over here my k is over here, and this is 0, 1, 2, 3, 4, and 5. So I'm saying that I'm bursting the balloon present at the second index. So I'm saying that this balloon will be bursted at the end after I get the output for partition 1 and partition 2. After I get the output for partition 1 and partition 2, then and only then I will burst this balloon. So I'll get maximum output for partition 1. So how many elements do you think I'll include in partition 1? I will include elements in the range I to k minus 1, because the kth balloon will have the coins value of its own, and this partition P2 will have the balloons starting from the value k plus 1 till j. This will be the range of partition 1 and this will be the range of partition 2. Okay, and what is the value returned by partition 1 and partition 2? It will be the maximum output that you can get for partition 1 and partition 2. Let's say they are A1 and A2. Okay, and on bursting the kth balloon, now I have bursted all the balloons of P1 and P2. So now what is remaining in my array? Only the kth balloon is remaining, because everything is cleared out both from both its left and right hand side. Okay, so if I want to burst this balloon, what is the amount of coins I'll be getting, that would be pay attention over here, that would be according to the formula. So what would be the formula? So the formula to burst the ith balloon is a of I minus 1 into array of I into array of I plus 1. This is the formula. But over here I am showing that everything will be covered from its left and right hand side. For this kth balloon, everything will be cleared out from its left and right partition. So every time, it is not possible that there can be a possibility that there are some balloons remaining in on the left hand side of partition 1, and there are some balloons remaining on the right hand side of partition 1. Okay, so if I was talking about this much part only, 3, 4 and 5, then if I was talking about this subarray 3, 4, 5, 3, 4, 5, then over here, if I took this part as pivot for this subarray, then what does that mean? Only this pivot element is remaining? No. There are elements, this many elements remaining on the left hand side after partition 1. There are elements remaining on the left hand side of partition 1. So over here, this formula, you will not directly use this formula, but the values will be different from this. So I'll be finding the value I'll be getting by bursting the kth balloon. So don't you think I should simply write down according to this formula? For ith balloon, I have the formula that was a of I minus 1 multiplied by a of I into a of I plus 1. So don't you think k minus 1 into k plus 1 will work? Don't you think this formula will directly give you the answer or the output, that is the value you get by bursting the kth balloon? Do you think this formula is like correct? You have to find out this value is nothing but the number of coins you get by bursting the kth value. So do you think this formula is giving you the correct answer or not? Okay, so I'm saying that now for partition 1, recursively I'll be calling partition 1 and I'll be getting A1. Recursively for P2, I'll be getting A2. Now only the kth balloon is remaining. So I need to find out that what is the number of coins I get by bursting this kth balloon. So for that, I already have a formula. That formula was, this was the formula that you get this many coins by bursting the ith balloon. So now I have to figure out that on bursting the kth balloon, what is the number of coins I get. So I used this formula. So my question was, do you think this formula is correct? It should be only ARR of K, right? Okay, yes. Rishit says this formula is not correct. Correct? Okay, so I'm saying that only. This ARR of K minus 1 into ARR of K into ARR of K plus 1 is according to the formula. This gives you the total number of coins you get by bursting the kth balloon. Okay, so I directly used this formula for kth balloon, and I'm saying this formula is wrong. Why? Because it is possible that there are balloons. If I'm saying that this was partition 1, this much was partition 1, and this is your kth balloon, and this much is your partition 2. Now you busted all the balloons of partition 1 and partition 2, but there is possibility that you are talking about this much of sub array only, but actually the array begins from this point. Actually there are elements present on this side as well. Okay, so this is your entire array, and you were looking at this much of sub array only. Your array starts over here and ends over n minus 1. You are only seeing this much of sub array. So if you directly use this formula, it will give you wrong answer, because you need the value of balloon at this point. This is your I, this is your j, this is your sub array for which you are calculating the answer. So you need the value of the sub or the balloon present at I minus 1th position. Similarly, there can be possibility that balloons are present on the left hand side of partition 2 as well. Now are you getting the imagination clear? So over here, you cannot directly use k minus 1. You need to use I minus 1 instead. I minus 1, and over here, not k plus 1, you need to use j plus 1. Okay. We need the value on the left of p1 or 1 if no other value is present. Yes, yes, and the value to the right of exactly, Rishit. If no other value is present. Yes, exactly. This is what I'm trying to say. Okay, so the imagination along with recursion is a little bit trickier. So this is the formula, and this formula will give you the number of coins you get by bursting the kth balloon, and this will give you the correct answer. Okay, and let's say you are storing it inside the value p3. Okay, so you need to add these values a1, a2, and a3. You need to add a1 and a2 and a3. That would be the output for the kth balloon. Let's call it as temporary. That would be a1 plus a2 plus a3. And finally, you need to take the maximum of all different temporary values. So we'll compare it with maximum. Let's say answer is the maximum value, and we'll be simply comparing with answer. Okay, so in this manner, this is the logical part inside the for loop. This is exactly similar to what I gave you at this point. The standard steps to solve the variation of MCM. Over here, the calculation on pivot. This is the calculation done on pivot. This is the calculation done on pivot element. Okay, so this is the equation which you need to figure out on variations of MCM. Okay, so I have almost completed the entire recursion part. Like the recursion part is written over here. It's clearly written. I simply need to write down the function names. Okay, so I will copy this part and write it down at somewhere else. Okay, so now let's clear this part. Let's make it a little bit tidier, right? Okay, and some algorithmic steps needs to be included. Okay, so our function has three different arguments. So what are those arguments? One of them will be the array itself. So I'm completing the entire function over here. Please pay attention. Okay, so this is my function, and over here I will be having an array list according to the question. So in the question you can see in Java you are having an array list. So I'll be passing this array list to that recursive function. Okay, so I'll be having the array list, and I'll be having the range values of the subarray I to j. So this is my function declaration part. Over here I need a base condition, so we'll figure out the base condition as well. Okay, so we'll figure out base condition. So this is k starting from I till j. We understood why I took I and j, both of them in the range for pivot, and now I need a function call. So function call, let me write down. The first argument is what? The first argument is the array list or a vector. So a function call. So this function call will be returning something. Let's say it is a1. Similarly over here function, again it will be called. So I'm just completing the syntax. And over here this is the formula, so it gives a direct constant value, right? So this will be a2, a1, and the constant value. I need to add these three values, so I can simply add addition operator, right? So this would be the addition part. Okay, adding this part, and the result of this will be your temporary answer. The result of it will be your temporary answer. Let me store inside my temporary variable. Over here is your temporary variable. Okay, and what? Let me clear it out. This part not needed. Okay, and over here is your maximum variable. So maximum variable, what does it do? This will be storing the final output, right? And this is your, I also need to declare your answer variable. I need to declare the answer variable. So let's say before this for loop, I declared the answer variable, and it stores the what kind of value? Let's say it stores 0 as an initial value. Okay, and over here a return statement, return answer. Clear? And now this was our logical part, pretty easier, and like this question is under hard section. But if you do not know MCM, then it's difficult for you. If you know MCM, this standard thing, then it's very easier. Clear? Is it clear? This much of part is clear or not? Quickly, yes or no? Okay, so let's move further. So let's talk about the base condition. Okay, so base condition, each and every time over here is your k, this is your partition 1. It starts from I and it goes till j. This is partition 2 and partition 1. Okay, and in partition 1 you have the elements from I to k minus 1, and in partition 2 k plus 1 to j. So each and every time the value of I and j will be trying to cross each other. So whenever the value of I is greater than j, then what does that mean? That means there are no elements inside your subarray. Your subarray is completely empty. So what is the answer for that thing? When your subarray does not contain anything, then that means the output is 0 for that subarray. The result is 0 for that subarray. Okay, so this is your one of the base condition. When the I and j cross their path, the output of that subarray is nothing because the subarray is empty. So you'll be returning 0 in that case. Okay, so that is one thing I need to add in my base condition. So when I is greater than j, return 0 as the subarray goes in negative. Nothing is there inside your subarray. And when your I and j both are having the same value, so when your I and j are pointing to the same element, what does that mean? So you're talking about a subarray that contains only a single element even. So if you have only a single element, then what is the number of coins you get by bursting the single element? So that would be according to the formula. So according to the formula, if you burst the ith balloon, you get array of I minus 1 into array of I into array of I plus 1 number of coins. So this will be the value you will be returning when I and j are pointing to the same element, because that means the subarray is containing only a single element. And what is the number of coins you can get by bursting a single element? It is according to the formula. So if I and j are pointing to the same element, you simply need to return this value. So let me write down array of I into array of I plus 1. Okay, so this was our base condition part. We cleared the base condition. We also did the logical part. So this is the entire brute force approach. This is our entire brute force approach. Yes. So we can quickly code the brute force approach, and then we can convert this brute force approach into the DP approach. Because over here, there are some sub problems on which you are calculating the values again and again. So you can avoid that part by storing the values of that subarray inside a table. So first of all, let me code the brute force approach quickly so you'll get a better idea. Okay, so I'll be writing down a new function. I'm coding it in Java, but the same can be done in other languages because everything is all about algorithm. So array range. Okay, so what will be the range? Okay, so in the beginning over here, according to the statement, assume an extra 1 at each boundary. That means at the 0th index on the left hand side, assume 1, and at n minus 1, after n minus 1, assume a 1. So what I'll be doing, I'll be adding the 1 at the 0th index, and I'll be adding the 1 at the end as well. 1 element. Value 1 is inserted on both the sides, on the left hand side and on the right hand side of this array. Okay, so now I'll be running a loop from 1 to n, because now I have added 2 elements inside our array list. our array, then what will be the size? So the size now is equal to n plus 2. Now what will be the range? So at 0th index, what is present? At 0th index, 1 is present, and over here are your array elements according to the input, and over here at n, what is this? This is what? N plus 1th index, you are having 1 again over here. The entire size of this array is what? It is n plus 2, because two elements are added, and at 0th index you are having 1, and at n plus 1th index you are having 1 present, and these are your input array elements. Okay, so over here, while calling the function, I have passed this range, that is from 1 to n only, because I'll be working on this part only. Okay, if you are having confusion with this thing, then you can ask it right now. Okay, so I'll be going on further with this function. So the first will be the array list. Okay, and over here let's write down the base condition. So if I is greater than j, you will be returning nothing, but what? You will be simply returning 0, because output is not possible. And when I is equal to j, then that means only single element in the sub array. If I is equal to j, what? You will be returning array of I minus 1 into array of I into array of I plus 1. This is the formula, and now here is our calculation part according to the pivot, around the pivot. Okay, so pivot will be running from I to j. Okay, so let's write down for integer k is equal to I and k is lesser than or equal to j, k plus plus. Okay, so let me turn on my camera as well, so it'll be okay. So now we'll be calling for left and right partition. Is this official channel? Yes, it is official channel. So for left partition, I'll be making a call from I till k minus 1, and for the right partition, I'll be making a call on k plus 1 till j, and the amount of coins I get by bursting the kth balloon will be array of I minus 1 into array of k into array of what? J plus 1. I already explained this part as well. And let's say I'm storing it inside a temporary variable. This is my temporary answer, and I need a maximum final answer as well. So I'll declare an answer variable initialized with 0, and now answer variable will contain the maximum value always. If answer is lesser than temp, then assign temp to answer, else assign answer itself. And from here, you can return the answer variable, because this is the max coins you can get by in the range I to j. So that would be inside your answer variable, and this is the entire thing. And finally, this function will return the value, and this would be the output. You can compile and run and see. Can you explain the range of 1 to n on line 7 or 37? Yes. Okay, so this is a syntax error. We can. So in the line number 37, okay, I'll explain it. Over here, I have used array list. So in Java, it's a little bit different. You need to call a method if you want to access the elements. Okay, so you cannot call the same manner in which you are accessing the array elements. You need to call a method, because array list is a class in Java. And over here as well, what? I minus 1. This is get method a plus 1, and now let's run and see. So this is obviously going to give you a runtime error, because you are trying out all the possibilities. And let's submit it. I will explain line number 37. Okay, so 37. Okay, just a minute. See, we got a time limit exceeded. Only 16 test cases were passed. So in line number 37, I'm calling the function with the value starting from, I'm calling with this initial values. Okay. So what is the reason? So over here, according to the question 1, 9, 5, 7, and 8, if this was your input array, the question says to imagine one present on both this end. So initially your array was looking like this 1, 2, 3, and 4, your array list or vector or anything. So now what I did, I inserted an element on the left hand side and on the right hand side. So the indexing will change. So if I want to write down the indexing in terms of n, so first of all, let's change the indexing. So let's change and see. This would be 0, 1, 2, 3, 4, 5, and 6. Initially, what was the size of the array? Initially, the size of the array was 5. Okay. So now I'm calling recursion on this part. That is, I is 1 and your j is nothing but 5. Okay. Was it clear, Rishit? So that's why you are using this value. Yes or no, quickly? Okay. So now, so now this is giving error because the time complexity comes out to be n factorial, because you are trying out all the possibilities, because at each and every point why it is n factorial, let me give you the explanation part as well. Because initially, how many elements are there inside your array? N number of elements. There are n number of elements, so you can choose any of the element. So if I'm choosing n this element, then in the next phase, how many elements do I have? I have n minus 1 elements. I have n minus 1 elements. And in the next phase, if I'm choosing any of the one element, I'll be having n minus 2 number of elements. So for this n value, there are different n minus 1 different possible combinations. For this n minus 1, I have n minus 2 different combination for each individual values. Similarly, for this 1n, I have different, for single element, I have different n minus 1 possibilities. So at each and every point, you will be having, so overall, you will be having this many different number of combinations, n minus 1 into n minus 2 into n minus 3 and so on into 1. So this is nothing but n factorial, and this will be not acceptable because it will take too much of time. Okay, so we need to optimize. So why this thing is happening? Because over here, if you observe carefully, I'm not I think there won't be any requirement of showing the dry run, that which step is repeated, like what is being repeated. So if you pay proper attention over here, if I was talking about this part, if I was talking about this array or this balloon present at this index, and if I'm saying that I will be bursting this and I will be finding out what is the output for partition 2. This is my partition 2. Inside this partition 2, if I'm, let's say, I am finding the output, let's say, for this balloon. Let's say I am bursting this balloon, and if I am bursting this balloon, I'll be finding out what is the maximum value I can get by bursting this partition. This is partition 2, 2, for example. So this is my partition 2, 2. And similarly over here, suppose if I am targeting this balloon for now, I'll be finding out maximum output for partition 2, 2, 2. Okay, in this manner you will keep on doing this process again and again. If you observe, if you pay a proper attention, you will be calculating there are each and every point, there are sub arrays which are repeated. Over here this much of part is repeated, over here this part is repeated. Similarly, if you go further, this part is repeated. So you will be calculating the values again and again. If you have calculated the maximum output for this much of range, let's say your I was over here and your I was over, G was at this point. If you have the maximum output for this range A1, so whenever you encounter this range, let's say it was 3 to 7, whenever you encounter this range, a function call is made on this range 3 to 7. You have already encountered this 3 to 7 and you got a maximum output as A1 for this range. So I'll store this value somewhere inside my tabular, inside my table, and then I will not again and again calculate the same value, but I'll get the value from this table, and directly return this value from this table, because I have already calculated the value or the answer for this range I to j. So this was the do you think, do you want me to show you where the repeated part is there, like which what do you call it, uh, overlapping sub problem part? Do you want me to explain with an example, or is it fine? Okay, so if you take an example and figure out, you write down the entire recursion tree, you will be able to see that there are some sub problems, some sub array range for which you are making the function call again and again. And in order to avoid this part, I will be storing the values for each and every range I to j inside my table. Can we try a small test case? Okay. 135 will be fine. Okay, so let me write down quickly 135, 1, 3, and 5. Okay. So for 135, this is one present over here and one present over here. Imagine one R present at both the ends. This is indexing 1, 2, and 3. Okay, so your K will be iterating from this to this range. If currently your K is at this point, at this index 1, you will you will be, let's say, function for 1, 2, 3. Inside this, you will be having a for loop where k will be running from 1 to 3, and function call will be made on which part? 1 to at different points. You will be making the function call. So from this, you will be making a function call on 1 to, let's say, 1 to 0. I'll explain what I'm writing over here. 1 to 1. This is all partition 1. 1 to 2 and function colon 1 to 3. These are all the different calls made for partition 1, that is on the left hand side of k. These are the different k values: I to k minus 1, I to k minus 1, I to k minus 1, and I to k minus 1. This is for partition 1. We know the partition 1 is from range I to k minus 1, and partition 2 is for k plus 1 to j. So for this, what will be your partition 2? So simultaneously partition 2 will be what? It will be 1, 2, 3, k plus 1. Okay, so k is, this is your k minus 1, your k will be equal to 1. Over here k will be equal to 2, k will be equal to 3. Okay, if this is your k plus 1 is what? 2, 2 to 3. This will be your partition 2 for this part. Now for this part, okay, so for this part, what will be the partition 2? It will be what? From k plus 1 to j. So k plus 1 is what? K is equal to 2. 2 plus 1 is what? It is equal to 3. 3 to 3. And over here, function call on k plus 1. K is 3, 3 plus 1 is 4, and your j remains as it is. So this is not valid, so it will be returning 0. Just saying this part. And your over here, you can observe 1 to 3 entire function is being called again, k minus 1. So this will not be called. So these are the different values you will be calling. This is the first one is partition 1, the second one is partition number 2. And over here, this is 2 comma 3. So I'm writing down a recursion call for 2 comma 3 function for 2 comma 3. So k will be having value 2 and k can have the value 3. For partition 1, you will be calling on I, this is your I, this is your j, I to k minus 1. So k I is 2, k minus 1 is what? 2 minus 1 is 1, and this will be your partition 2, that would be k plus 1 to j. What is k? K plus 1 is 3, 3 to 3, and so on. So if you observe in this manner recursion tree, you will observe that a repeated function call is being made, and in order to avoid this part, you will be storing the output in I comma jth position. So now over here, I will directly memorize this entire brute force approach over here itself. So I'll be having a DP array, and all the values inside that DP array is going to be -1 initially. That means none of them has been visited. Okay, I'll initialize the DP array with -1, and what will be the size? For simplicity, I'm taking n plus 2 cross n plus 2 DP array. And what is the reason? The reason that I'll be explaining, because I have inserted, because the indexing have been shifted from 0 till, earlier the indexing were from 0 to n minus 1, but now the indexing have been changed from 0 till n minus 1 to 1 to n. Earlier it was 0 to n minus 1 for the input array, but now for the input array I have inserted 1 on both the side. So the indexing has changed from 1 to n, because the array is now bigger because two elements are inserted. So for you will not make it messier if you create an array of n cross 2, n cross 2 size, n plus 2 into n plus 2 size. That is the reason behind having this part. So over here, this is your base condition. So it, at each and every point, what do you need to do? So if you are calling for this I to j range, so whatever is the value you get at this part, whatever is the maximum output, you will store at dp of I comma jth index. Okay, so what is the maximum output for the subarray I to j? That output is stored inside your answer variable. That output is stored inside your answer variable. So what I'll be doing, a simple modification at this part. So earlier only return answer statement was present. Now I have added that I will store it at I comma jth index, the value of my answer variable, and I will be returning it. So over here the answer is calculated for I to j range, and similarly at this condition as well you are calculating the output. So you also need to store this part at I comma jth index inside your dp array. So you will add a statement I comma j is equal to array of this value. So this is entire memoization part. You have already memoized it, and you have converted it into a dp solution. Only a single thing is remaining, that if at any index, if you are again visiting I comma jth subarray, you will check inside your dp array that if the value at I comma jth index, dp of I comma j, if dp of I comma j is not -1, that means you have already visited that subarray and you have answer for that subarray. So you will be directly returning the value at I comma jth position. So this will avoid repeated calculation of subarrays, the answer for different subarrays. Okay, so this was entire memoization part. Only three statements were added, only three statements, and we directly converted into a memoized solution, and it is obviously going to work very fine, like very properly. And I'll explain why the time complexity and what is the time complexity. Till now, any doubt in this memoization part? Can the DP table size be n plus 1 cross n plus 1? See, if you are doing it not n plus 2 into n plus 2, then let's say if I am changing it to n plus 1, then you need to, yes, you can do n plus 1 till n plus 1 as well. Yeah. If you do n plus 1 till n plus 1, that's totally fine. But if you do it n, then you need to somehow over here you need to do some kind of modifications, because the indexing originally was from 0 to n minus 1, and now it is changed to 1 to n. So you need to figure out at which index you will be storing. You need to convert it into minus 1. Simply do minus 1 and it is going to work fine. As Rishit is saying, it can be n plus 1. Yes, it can be n plus 1 as well, because it is covering the range. The maximum value is n for row and column, and the minimum value is 1. That's what I need. Okay. If the minimum value would have been 0 and n minus 1, then I need to do some kind of operation, that is subtract 1 from I and j. Whenever I'm calling this one over here I and j, you need to simply do minus 1. So for simplicity, I'm keeping it as n plus 1 and n plus 1. Okay, so let me quickly code this part. Yes, Rishit, okay, I hope you got your answer. You can create an array of size n plus 1 and n plus 1. Okay, so over here let's add the dp part. So I'll create a dp array, 2d dp array. Okay, and before calling these recursive function, let me initialize this dp array, n plus 1 till n plus 1. Now initialization, I need to initialize it as minus 1. So I'll be calling it I is lesser than or equal to n I plus plus. You can use meme set if you are using vector, I mean C++. Meme set, you need to iterate over all the rows and then you use meme set on each and every row. Okay, not directly. So dp of I and j is going to be equal to minus 1. So this indicates none of the cell is visited. Okay, so at each and every point I will be adding a simple statement that dp of I and j will be stored at this part. And now if dp of I and j was already calculated not equal to minus 1, then return dp of I and j. And at this point I will be adding dp of I and j, answer value at dp of I and j, and that's it. Pretty easy, nothing fancy. Okay, so we got the output and now let's submit and see. Obviously it got accepted, and what is the reason? Let's understand. So the reason of it getting accepted is the time complexity. So let's figure out, let's understand what is the time complexity. So what is the size of the dp array? It's n plus 1 into n plus 1. I can consider it as n cross n for simplicity. Okay. Now what is I and j? I and j are iterating over how many values? They are iterating over n cross n values, because n cross n values will be visited. Okay. And at each and every combination of I and j, I mean, how many I and j combination can you have? You can have n cross n I and j combinations. Okay. I'm not saying all of them are going to be valid. Let's say 0, 1, 2, 3, and 4. Let me explain. Okay, the invalid part is when I is greater than j. So if I'm saying this is I and this is j on my dp array, so whenever I is greater than j, so where do you see I is greater than j? If I is 1, this point, at this point over here, I is greater than j. So over here, if you take a look, when I is greater than j, this part, at each and every row, this much of part is of no use, but this will be visited once, because you are trying out all the possibilities. Okay, as you are trying out all the possibilities, these cells are going to be visited at least once. So how many cells are there? N square cells are there. And what is n square? This is the total number of combinations of I and j. And for each and every valid I and j, you will be iterating over I to j for each and every valid ij. So at max, what is the number of iterations over each and every combination of I and j? So at max, the total number of iteration for k in the range I to j is n. So let's say there are different values of I1, let's say, and j1 over here. The initial the iteration of pivot is n over here. For another combination I2 and j2, the total number of elements over which uh, pivot is iterating is n. So in total, for n square, at each and every time at max, your pivot will be iterating over n number of times. So n square into n will give you n cube. So this comes out to be your time complexity. So for all valid I and j, your pivot will be iterating over n number of times when I and j are valid. Okay. So overall, and that is the reason the time complexity comes out to be order of n cube. So the time complexity comes out to be order of n cube. And talking about the space complexity, it's pretty clear, order of n square dp array. Was it clear? Any doubt in this part, time complexity part? Quickly in the chat box, yes or no? I will share the link of this code as well. So I have already generated a link. So let me share in the chat box. No, no, no. The brute force was not order of n. It was yes, yeah, order of n factorial. Okay, I thought it was order. You were saying order. Yes, the brute force is n factorial. Yes. Any part like which you are not able to understand anything? Okay. So this was the entire logical part and algorithmic part for the question. Maximum number of coins. Okay. So you can try understand more clearly if you know MCM problem. Okay. And the standard way to solve all the variations of MCM, that is matrix chain multiplication. So that's why in DP all the standard problems are very important, and that's why focus more on the pattern of standard problems, on how to solve the variations of standard problems in DP. Okay, so that was it. So I hope this session was informative. You guys enjoyed this session and you were able to understand the algorithm very easily. Okay, so that was it for today's session. Thank you everyone and good night.